Geography. Dun dun da. Physical geography. Chapter 3, part whatever. I think we're in part 6. Clouds. So, we all see clouds, and now we're going to learn really more about them. But what are clouds? Most people think it's actually water vapor. It's not. Like I said before, clouds are basically tiny little droplets of water or ice that are floating in the atmosphere. And clouds basically have three forms. There's many more subforms, but we're going to focus on three main ones. And the form of the cloud is defined by its shape. So we have cirrus, stratus, and cumulus, or cirriform, stratiform, and cumuliform. And as their names say, cirrus clouds are wispy, and I'm going to show you examples. Stratus clouds are layers of clouds like sheets, and cumulus clouds are puffy clouds. A fourth category is kind of a mixture. It is a nimbus cloud. A nimbus cloud is a cloud that makes precipitation, rain or snow or sleet. So a cirronimbus cloud or a stratonimbus or a cumulonimbus cloud. So a cumulonimbus cloud is a cumulus cloud that is making rain, a thunderstorm. Let's talk about these in detail. Now, the cirrus cloud, wispy. They look like high strands of feathers. They're very wispy. You might see them often like in a summer day where they're very high up. They look like little cotton strands or sometimes even like small jet entrails. They are usually ice. So they're very high in the atmosphere and very thin. Okay. Cumulus clouds, these are the kind of clouds that look like long, low sheets. They're flat. And the cumulus part means they're fluffy on top. So when you were a little kid and they said draw a picture of a cloud and you draw this big, huge, fluffy cloud, that was a cumulus cloud. The last one is a stratus cloud. And a stratus cloud is basically you don't really see the fluffiness. It's just long and flat. These are the kind of clouds when it's a rainy day and it's just gray all around or a gray, foggy day. Sheets of clouds like that. So for instance, we talk about the stratus. If I get my mouse to work here, right? A nimbostratus is a stratus cloud that is making rain or sleet. The cumulonimbus is a thunderstorm. So here is the clouds. Here's cirrus, kind of wispy. Don't worry about alto. This is from a textbook. I don't really get into the subcategories. Cirrus, stratus, right? Just loads and rows of shows. And cumulonimbus, big fluffy. Here's another example. Here's a cumulus cloud, right? Big fluffy cloud. If it gets really large, it becomes a cumulonimbus. And you can see that's usually when you have a thunderstorm. A stratocumulus, don't worry about that. You have a stratus, sheets of clouds. Okay. Jet contrails, by the way, if you see a jet plane, those little things, that's actually not a cloud. That's actually just water vapor being released by the engines, like exhaust. Well, people often say, well, isn't cloud or fog a cloud? And it is. If you're in fog, you are basically in a stratus cloud that is at ground level. Remember in the last section we were talking about clouds form at a certain level, the LCL. The LCL is the altitude up high up in the air where the air becomes so cold that the clouds form. Well, what if that level was on the ground? In other words, what if the temperature of the air, the dew point of the air, is 45 degrees and it's 40 degrees out? That means the fog, a cloud is going to form, a stratus cloud actually, at ground level. And that's what fog is. We often see what's called radiation fog, and these occur in valleys. And I'm going to show you in a little bit. But valleys have the situation where usually in a valley, right, the tops of the edge of the valley, they get sunlight first. They warm up. The bottom of the valley is in shadows, stays colder, and it allows fog to kind of hang in the valley. And the one that we will talk about also here, we see this in Chicago, advection fog. This forms when you have a body of water that is either warmer or cooler than the land around it, like Lake Michigan. So here is radiation fog. I want to say frog every time. If you ever go to California, right, here's San Francisco, here's Los Angeles. You have this row of mountains right on the coast, the coastal mountains. And then you have the Sierra Nevadas here near Nevada. And in between you have what's called the Central Valley. So it's this big, wide valley between two mountain rows. And so what will happen is, sometimes in the certain times of the year, it'll be a fog that forms here in the valley because it's warmer here first. You can see right here, this valley in Spain, full of it. But the one that you're all probably familiar with here, advection fog. San Francisco gets this quite a bit because San Francisco is right on the ocean, the Pacific Ocean. And right here, the ocean is actually usually very cool. The ocean water here is usually between 40 to 50 degrees. And so if the water is 40 degrees, that means the air above it is 40 degrees. So the air is cool, and because it's above water, pretty moist. If it blows on land, right, and the LCL is such that the temperature there, it'll turn into fog right away. And I always think about this. If you've ever been to Chicago, certain times in the winter or the spring or the summer, right, and it'll be foggy over Lake Michigan. So a good example is early in the spring, right, say in April or May. The water in Lake Michigan is still probably 35 degrees, very cold. And the air above the lake is very cold. It's because the air cools it. So there's water vapor in the air, right? But it's very, very cold and it doesn't hold much. But now that blows onto land. And what if the land is even colder? So what if it's 35 degrees over the lake, but only 20 degrees over the land? And so that means the air is 20 degrees. And this cool, moist air blows onto land like a Navy pier right along the lakefront. And all of a sudden, it's over even colder land. The air is going to chill, and it's going to take any moisture in it and turn it into fog. And so that's exactly what you get. So the other aspect is precipitation. So again, what goes up, right? The water that goes up as water vapor eventually comes back down. And it makes a couple things. The first one is rain. And rain is formed through two processes. Condensation drives it, but then collision and coalescence. So what takes a cloud, right? What takes a cloud and turns it into rain? Because remember, a cloud is liquid water. What makes it rain? Something has to happen to make those tiny little droplets sink back to the ground. And what happens is you start with what they call this kind of molecule, this small particle in the air. Something that is floating in the air. It could be bacteria, it could be smoke particles, dust, ash. Something that's tiny and floating in the air, an aerosol. When it encounters water, remember what does water like to do? It likes to adhere to things, doesn't it? So you have this piece of dust in the air or smoke, and it comes into contact in a cloud. And as this cloud of dust, all these particles of dust go through the cloud, as they're moving through all these droplets of water, water sticks to it. So now you've got a piece of dust and water sticking to it. And that's the condensation nuclei. And what happens is these grow. I'm going to show you a graphic, right? And eventually they become big enough to become raindrops. So rain forms with condensation and collision, right? Don't worry about the temperature. Basically, it has to be above a certain degree. But here's what happens. Here you've got all this water vapor in the air, but nothing for them to stick to. They're floating. And now blows in a dust storm. Tiny little droplets of dust. I mean, we're talking 1/1,000,000th of a millimeter. And what happens is water sticks to it. So one particle of dust floats by, and a droplet of water sticks to it. And it floats by, and now it hits another drop of water, and it sticks to either that water or that dust. And so now more and more water is sticking to that dust. And so that's the condensation nuclei, and it grows. And maybe it hits another condensation nuclei, and they stick together, right? Now eventually, if this keeps on happening, if this coalition of water nuclei or coalescing water forms, eventually, when the water droplet grows to be 8 millimeters, which is, you can't even tell, but very tiny, at that point, the weight of the water is enough to overcome gravity, and it begins to sink. So raindrops form when these condensated nuclei become over 8 millimeters. And it's actually formed of millions of merged cloud droplets, and within them tiny microscopic specks of something. So that's how rain occurs. If it wasn't for the condensation nuclei, the water would eventually settle out, maybe as a mist, maybe not, but it would never rain. Now, that being said, they've tried over the years. We know this in principle, and some people have said, well, what would happen if we just flew an airplane through a cloud and released a canister of dust? Could we actually make it rain? And scientists have been trying for years with mixed results. There's a lot more that goes into this. This is a very simplistic explanation. There's a lot more science that goes on that we still don't quite fully understand. Now, snow is very similar. But because it's colder, it becomes ice crystals. Because now, if the temperature of the cloud drops, the water molecules in it will become ice. And so the same thing happens. You have something as a nuclei forms, and then the ice crystal forms. So the ice crystal forms. And remember that when water freezes, right, it forms those hexagon bonds in the form of a hexagon, the six-sided. That's why snowflakes have six sides. And these initial ice crystals, they call them ice nuclei. They're basically a flat plate of ice. And as this little tiny flat plates of ice, it's still very small, is floating through the crowd. If it encounters other water or other ice crystals, they kind of stick together and they grow. And just like it does with rain, when these snowflakes get big enough, they finally get heavy and fall. So if you look right here, here you have, right, water droplets. They're sticking to each other. Maybe there's an ice crystal they stick, and they grow to each other, and they stick. And the bigger it gets, the heavier it gets. And every time this happens, it forms another hexagon. That's why if you look at ice crystals, it's hexagons upon hexagons upon hexagons. They say that no two snowflakes are ever alike. Is actually not true. It's just statistically so improbable you will ever see two alike. Because if this water molecule freezes just a half millimeter here or there, different patterns form. Theoretically, you could make uniform ice crystals, but nature is very random. But that's why you always see this six-sided plate. It's hexagon upon hexagon. Things only join with these angular features. And eventually these grow so big that they fall down. Sometimes what happens is also the what they call the shattering process. You have this crystal right here. It falls, it hits another crystal, they shatter the other little drops. So it goes from being a snowflake that was falling, it shatters into many smaller ones which still float, and those grow into new ones on their own. Now, the other type of precipitation we haven't talked about is hail, which are big balls of ice, but those are the exception. All rain, all snow, all sleet, all freezing rain starts with one of those processes we talked about. As to what type, is it rain, is it snow, is it sleet, freezing rain? That depends on what they call the temperature profile. How warm is the air where it forms? How warm is the air at ground level? And what is the temperature of the air as it falls? So let's look at this image. We've got this huge cloud. At this level right here, the air temperature is above freezing. So any type of precipitation formed here will be rain, because it's above freezing. This right here, between 0 and 15 Celsius, or 32 and 5 degrees, sometimes rain can form up here as ice, but it'll melt by the time it gets to the ground. So this area could be snow or rain. But at this point right here, when it's this high up, it's negative 15, it's going to form ice crystals. It'll fall. The only way that it won't fall as snow is if it's too warm right here. But what if the temperature right here on the ground was 20 degrees? So anything that falls up here would actually form as snow as well. So, here, another example. Right here at about 3,000 feet, the precipitation forms as snow, right? As it's falling, at about 1,500 feet, the temperature of the air warms, and now it is above freezing. So even though it started as snow, it ends up as rain when it hits the ground. But what if it stayed below freezing the whole time? Then it would stay snow the whole time. Now, once in a while, you'll get that sleet, right? That's that kind of stuff where it's like not really rain, but it's not snow. It's kind of that mushy stuff. That happens when you have kind of a weird, they call it inversion, where the precipitation forms up here at 3,000 feet. It's cold enough to be snow, but as it falls to the ground, it encounters warm air, so it melts into water. But then, as it gets closer to the ground, it gets cold again. So if you have some kind of like warm level of air here, a temperature inversion, it starts as snow, it melts back into rain. It doesn't quite freeze all the way back, so it's kind of half frozen. That's sleet. Freezing rain is the same thing, but you really can't see it because of my image here. The difference is this part where it goes from snow to rain being frozen again is much closer to the ground. And so what happens is the raindrop hits the ground, it's cold enough to be ice. It just hasn't frozen yet because it hasn't enough time, but it is cold enough. When it hits the ground, that action of it hitting the ground and that release of energy, the movement stops. The energy is basically thrown off of the rain and it instantly freezes. So that's when you get that ice storm where everything is coated in a glaze. It's not very common because it's a very specific set of circumstances. I know I tell you guys that I normally keep these videos 10 minutes and we're almost at 15, but we're right here at the end. Hail. I want to finish this slide and get done with this for you guys. Hail is the unique situation. Hail forms in a different manner, and it has to form in a very specific manner. It's why it's very rare. It has to, first of all, form in a cumulonimbus cloud, a big, huge thundercloud, and a very, very big and strong one. That's why you normally see hail as severe weather. Now, hail, if you don't know, I hope you do, is basically chunks of ice that fall down. They can be anything from the size of like pea, little vegetables and stones, to the biggest one was the size of a softball, about this big around. Okay? The size of hail is dependent purely on how strong the winds are in the thunderstorm. The stronger the winds, the more strong the storm is, the bigger the hail. Okay? And so that's why a lot of hail is not really too damaging. It's just little things. But when you get hail that can be the size of a golf ball, right, that can damage cars. It can dent windows or dent cars. It can break windows. The biggest one ever recorded was the size of a bowling ball and weighed 2 pounds. That would kill you if it hit you. Okay? It destroys crops, so it knocks plants down. It can destroy property. It can break windows. I remember a few years back there was a huge hailstorm in the area, and local car dealerships had their cars parked outside. All the windows were broken out, and all the cars were dented. So they had a huge sale, right? What are you going to do? Here's how it forms. You've got this big, huge cumulonimbus cloud. And we're going to talk, I believe it's next chapter, about how thunderstorms act. But there's a lot of energy here in the form of winds. And so here you have warm, moist air being pulled up from the surface of the earth up into the cloud. And once it gets above this high, the air temperature, right, is very cold. So it turns into ice. So the ice process begins. But instead of being snow, right, as that piece of ice comes down, normally that would become snow, right? But something happens to blow it back up. There's so much more energy that ice never gets below that level. It's constantly being moved up and down here above freezing. They call that grapple. It's basically ice. And what happens is every time that ice goes down and starts to fall and gets pushed back up, another layer is added and added and added. It's like rolling a snowball on the ground to make a snowman. It's the same thing. And the chunk of ice gets bigger and bigger and bigger and bigger. Finally, it gets so big, it weighs so much, the wind can't keep it, and it begins to fall. And as it falls, it brings down cool air with it. You get these huge downdrafts, so cold air blowing down with lots of hail. Normally when you see hail, this is something we'll talk about, it is indicative of very strong, violent weather, the same type of weather that can create tornadoes. So as we'll talk about next chapter, usually hail is accompanied by a tornado warning. But this is how big it can be. This is actually a 2-pound ball of ice. You can see it's almost 20 inches around. That would go right through a roof or a car. If it hit you, you'd be dead. So hail can be very damaging. All right, that's it for this chapter. Thank you for sticking with it. We'll talk to you later.